After the course objective, we have to choose some examples or some drawings for the completion of this project. For this, I'm gonna choose this architecture plan, which is really good because it covers the concept of brass frame and moment resisting frame, as you can see here. And this is the south elevation part, this side and this side. These are the openings, and this side is totally just the wall. And talking about the project information, I'm going to tell you about the project information. As you can see here, the major project is focused on steel structure design of the 5-story residential building. For this example, we're going to choose the 5-story residential building, and you can see this is the Sydney CBD because I'm working on Sydney, Australia. That's why I'm covering these lectures uh, as the Australian standards, but you can take as a reference for other standards as well. And there is some information. The working life is 50 years. Working life is 50 years, and we have to choose the concrete grade of 32 MPa, and the composite floor including reinforced concrete slab is 100 mm. But before that, we have to confirm the 100 mm is sufficient, either sufficient or not. But this is from the questions, and here is a criteria. The lateral resisting system in x direction, which is moment resisting frame. This means we have to use the lateral resisting frame, which is in the short direction, which is moment resisting frame. That means which is short direction, right? Yeah, okay. This direction, because we have a big opening. That's why we cannot use the press frames over here. We have to use the moment resisting frame, and I will explain the what is moment resisting frame and what is brass frame. I will explain it later, but for now, because I'm just in questions, that's why I will explain all these things for the following lectures. That's why, okay. Brass frame in the lateral y directions and moment resisting frame in x directions. Okay, there should be a moment resisting frame and there should be brass frame from the questions. Okay, let's go to the project informations, and there is some criteria. We have to choose the superimposed dead load as a 2 kPa, which is floor finishing, include a floor finishing and partitions. But we can also check from the course as well, which 1170.1. and these are the models, these are the SAP models, and this is the Tekla models, and this also too. Talking about the steel design requirements, there are some requirements. We use the dead loads or lap loads for the 1170.1, and for the wing load 1170.2. These are the Australian standards, and we have to create the 3D models of the building in a SAP. That means we're gonna use the SAP for the design of steels. Then we have to determine all the loads and then apply to the 3D models, because so we have to determine all the loads from this course, and after that we have to apply these loads into the our 3D models. After that we have to run the analysis in a SAP, and after that we have to check the validity of the structural model using the hand calculations method, which will be discussed in the first lecture, because after this project information I'm gonna discuss all these things. Yeah, after that carry out the steel design and optimization SAP. After the designing, the optimization plays a very important role, because like for the economical design, optimization is very important, crucial. And after that we have to check the inter-story drift, because we are designing our structures as a for the wind load. That's why inter-story drift is very plays a very important role, and which is based on a clause. This means we have to check our parameters according to this clause, because this means I think this is Australian code of concrete. Yeah, this is concrete code. Yeah. Design of all steel connection. For the steel design of the building, steel connection plays a very important role. Yeah, exactly, because due to the wind load actually a lateral load. That's why connection plays a very crucial role. Yeah, I'm not joking, it's very crucial. That's why we're gonna use the beam column connection, bracing connection, and base plate connection through the software as well as manually. But we focusing on manually, because manual, if you understand manually, then software is not that hard, it's easy. But I'll show you all the process, don't tell you about that. Okay. Yeah. Design of the composite floors, uh, which is based on 2027.1, which is 2003. This is the Australian code, which is for the composite floors. And after that, you also learn about how to make the design report, and after that we can prepare the detailed structural drawing for the all components. For this, I'm gonna use the tech structures. It's very easy, and this is the design report format. It actually is not necessary, because I'm gonna tell at the end, because we have to know. For this we have to the SAP models, 3D view, and all the design calculations. Yeah, that's it's not that important. So for this lecture, I'm going to cover this architecture plan. You can take a snapshot and you can go with me for this. First, I'm going to use the SAP for this modeling. For this, there are not details drawings over here. As you can see here, there is a little bit shift of this column, this because this is not in the grid. That's why I'm gonna first export this drawing into the AutoCAD, but I already export it into the AutoCAD. If you want to like export this PDF drawing to AutoCAD drawing, then comment me in the comment section, then I will also include this part as well.